Matter is anything that has mass and takes up space and all the stuff around us. Welcome to today's lesson as we talk about matter a little more in depth and we look at what makes it up and how we classify it. So today we are going to understand the differences by the end of this video, hopefully. You're going to understand the differences between chemical and physical properties, so two ways we talk about matter. We're going to be able to classify things as elements, compounds, solutions, and heterogeneous mixtures according to what you're given and based on your information. And then you're going to use your knowledge of chemical and physical properties to determine if a chemical or physical change has taken place. So we're going to talk about changes to matter as well. All right, so to start, if you can imagine you had a mix of coffee grounds, iron fillings, and table salt before you. So coffee grounds, iron filings, sorry, not fillings, filings, and salt in front of you in a bag or in a container. Your task is to separate these things. How would you do that given these different constraints? You have a magnet, you have beakers, you have a spatula, you have ice if you need it, you have filter paper, you have test tubes and rubber stoppers, along with Ziploc bags, watch glasses, tongs, paper towels, funnels, and ring stands and burners. So think to yourself, set up a demonstration. How would you separate these materials, these things, so you can have your salt in one container, you can have your iron filings in another container, and you can have your coffee grounds in a third container. How would you go about doing this? And once you have that, we will continue on. So you can pause the video and complete that. All right, we are talking about matter. And matter has two types of properties we're going to talk about, actually more, but right now we're going to talk about two types. We're going to talk physical and chemical. So physical properties. We talk about physical properties, we're talking about physical characteristics. These are things that you can observe and or measure. For example, we have mass, we have volume, we have color, we have boiling point, we have melting point. We can either see this, so I can see it's red color, or I can measure something about it. So I can measure the volume, I can measure the mass, I can measure boiling points and melting points with thermometers, so on and so forth. Chemical properties, in order to see these, it has to have a chemical change or a chemical reaction take place. Without that, we have no idea about these properties. For example, I can't look at something and say, yeah, that's flammable, or that reacts with oxygen, unless I've seen it do so previously. But again, I've already observed this chemical change that took place. So chemical properties have to have some sort of reaction take place in order to witness and see happen. Other ways we can describe properties is we can use these terms called extensive and intensive properties. So if we are talking extensive properties, think of extensive as external. So this depends on the amount of how much external stuff you have. So extensive depends on the amount of matter present. For example, volume. If you have more stuff, you have more volume. Likewise, if you have more stuff, there's more mass there because there's more stuff. And then energy plays into that as well. We'll talk about energy more later on. Intensive, on the other hand, are things that the amount of matter does not change it. Things like melting point and boiling point. Whether you have 100 grams of water or 200 grams of water, they both boil at 100 degrees Celsius. They both freeze or melt at 0 degrees Celsius. That doesn't change depending on the amount of water. Density is the same way. Density is grams per, or mass per volume. And so density doesn't change because you're changing both, but it comes down to the same thing. Conductivity, more stuff doesn't make it more or less conductive. And specific heat is something we'll talk about at the end of the year. But that deals with how much energy is required to change the temperature of a substance. But that doesn't change either with the amount of substance, because we're still talking the same material to begin with. If we're going to classify this matter, we can do so, and there's a couple ways we can split it up. So if we're talking about matter, we have pure substances and we have mixtures. So we're talking with pure substances first. So pure substances have what we call a fixed composition, and you can't separate them. You can't separate particles. So fixed being all of them are the same. So think of water, for example. Water is a pure substance that has a fixed composition. What is the composition of water? Well, you've known for a long time, I believe. that water is H2O. So every water molecule has 2 hydrogens and 1 oxygen. What if I had 2 hydrogens and no oxygen? Well, then I'd have oxygen gas or hydrogen gas. What if I have 2 hydrogens and 2 oxygens? Then I have hydrogen peroxide. So that's a different substance than water that we drink, H2O. So compounds are one type of pure substance. Water is an example. Has 2 or more different elements chemically bonded together. So we can't separate these hydrogens and oxygens and still have water. And we can't physically pull these two apart anyways. I can't take a water molecule and split it and say, here's the hydrogen over here, and here's the oxygen over here. It doesn't work that way. We can use a chemical means, a chemical change, and we can separate them absolutely, but we cannot physically separate them. It's a much more in-depth process than that. So if compounds is one pure substance, elements are the other. So elements are the simplest substance that retains all of its properties. And so elements are the substance that cannot be broken down into simpler substances by chemical means. Once you get down to just hydrogen or just oxygen, so I have 2 hydrogens or 2 oxygens bonded together, we'll talk about that later. That's as simple as I can get. I can get down to a single iron molecule. So I can have 1 atom of iron. That's an atom. That's an element. I can't get any smaller than that. If I get smaller than that, then I'm changing the substance. I no longer have iron. I have magnesium or manganese. I have cobalt. I have some other element that's not iron. Those are pure substances. These are mixtures. So if we're talking mixtures, mixtures are a physical blend of 2 or more kinds of matter, with each part retaining its own identity and properties. These can be separated by physical means, sometimes with tedious physical means, and typically we describe these in terms of mass or percent mass or percent volume. But these are mixtures, and there's 2 kinds. We call these homogeneous or homogeneous and heterogeneous. If they are a homogeneous mixture, they are uniform in composition, meaning they look the same, they have roughly the same composition all the way through. Think of a smoothie. The first taste of smoothie and your last taste of smoothie should be the same. That's a homogeneous mixture, or we call these solutions. Anytime we mention solutions, we're talking about a homogeneous mixture. If we're looking at a heterogeneous mixture, these are not uniform throughout. Think of a blizzard. If you have a cookie dough blizzard, does every bite have the same amount of cookie dough and ice cream? Well, no. That's not realistic at all. So that's a heterogeneous mixture. Pizza is another fantastic one. You can separate a pizza apart. You have the crust, you have the sauce, and then you have your toppings that you can separate out. So that's a heterogeneous mixture. So we have different kinds of matter, and now we have changes to that matter. So if we have physical properties, we also have physical changes. So a physical change is a change in size, shape, or state of matter qualifies as well. This does not change the chemical makeup of your substance. So this does not change what substance you're talking about. So if I cut a piece of paper, is that a physical or chemical change? Did I change? Am I still talking about paper? Is the question. And the answer is yes. As long as I'm still talking about paper, whether it's here or whether it's here, my paper is still paper. That's a physical change. I changed the size and the mass and the shape of my paper, but I didn't change the paper itself. Chemical changes are changes to the chemical makeup. And we have some clues for a chemical change. So 1, you see a new substance form. So something that wasn't there is now there. If I mix 2 liquids and I get a solid down at the bottom, so if I have 2 test tubes full of a liquid, and I mix those 2 and I get this test tube that's got a liquid and there's a substance down here, this substance is called a precipitate. So that would be a new substance, that's a new material there, that is a chemical change. If this mixture solution of these 2 mixtures put together heat up or cool down, that's a chemical change. Something had to cause that temperature change. If they stink when you mix them, another chemical change. If they change color, likewise, I'm still changing things. If gas is given off, so when I burn something, there's gas given off. That's a chemical change. And if light or sound is released, that is also an indicator that a chemical change has taken place. All right, so those are properties and changes to matter. I would like you to take some time, answer these questions, or just even in your head, you don't have to do it on paper. Make sure you can answer these. If you have questions, please let me know when you return to class, and we will discuss them so that you can understand matter a little bit better. But answer these 3 questions, pause the video and do so. Here's a couple more. So I want you to name a chemical property of gasoline for the first one. And then I want to know which ones of these are physical changes. So A through G, which ones are physical changes as opposed to chemical changes? And then I have one more slide here as well. The last one, I want to know if this is a homogeneous or heterogeneous mixture. And then I want to know whether these substances, these items are pure substances or mixtures. Are they the same, fixed in composition, or do they change? Answer those as well. Make sure you can do this, and then I will discuss things with you more next time you're in class.